So hello everyone, welcome back to my YouTube channel. In the previous video, we discussed about common table expression using the with clause, which is used to create a temporary name result set, which you use to reference is like a result set that you can reference like a virtual table inside a single query. Now we are going to move ahead further step, that is learning today about recursive CTEs. What do you mean by recursive CTEs? So basically it is that CTE that is allowed to refer back to itself. So it can keep generating new rows and out of that rows it just produce. So it will produce rows and they generate using that rows, they generate more rows. So it is just like a loop inside the SQL. So you must have studied in other languages about recursions. So it's the same way it is working in SQL also. So we will study about the recursive CTEs in more detail. Let's get started. So basically, why do we need recursive CTEs? So let's say there is a hierarchy, like it says CEO, manager A, manager B, and their employees, employee 1, employee 2, employee 3, employee 4. And likewise, there are more levels. There are 3 levels, 4 levels, 5 levels. We don't know. There are multiple levels and there is a hierarchy like this. So if this is the case, if someone asks who are all the employees under the CEO and I want every level down, then the another question can be who all are the employees under the manager A specifically. So these can be the questions that can be asked. We have already studied about this example while learning self-join. I hope you remember that. If you haven't watched other videos, do watch it. The link is in description. Okay. So basically, if you use a single self-join, it will only walk us to the one level. That's easy because you know how many levels there are exactly. Okay. But what if the case in an organization, in the real world organization, this is not the case basically. A particular hierarchy can have 6 levels, or some hierarchy can have 5 levels, some hierarchy can have 4 levels, any levels it can have, right? So in that case, if you use recursive CTEs, so it removes the need to know that how much depth we have in advance. So we have to write the query once and the database keeps applying it recursively until there is nothing left to find basically. So this is the recursive CTE's main idea. So what is recursive CTE? It is a CTE that references itself to solve problems with unknown depth. So in this particular thing, we have two things basically, base case and recursive member. What is this base case? It is just a starting point. And recursive member is that particular thing which is referred to the CTE itself so that it can work recursive. To make it clear in more easy way, I can tell you that let's say you have to climb the staircases. So what is your first step? Your first step is to stand on the stair 1. Okay. And what is the next step? Next step is to stand on the stair 2, then stair 3, then stair 4, and so on. So instead of writing like this, step 1, step 2, step 3, step 4, you can write the initially or the first step is stand on the stair 1. And step 2, we can write move to the next stair. Move to the next stair from where you are standing right now. Until until there are no more stairs to climb. Correct? So basically here my base case will be stand on stair 1 and the recursive member here will be move to the next stair from where you are standing right now. And the stop condition here will be until there is no stair further, till that you have to move to the next stair. So this is what the recursive CTs do. So it has a base case, it has a recursive member, it is repeated until a stop condition is there. And when the stop condition is true, basically whatever result is there, that is my final output. So I hope you are clear with what are recursive CTs. We'll also try to solve some examples so that it will be more clear to you. Now, where are these recursive CTs used? So these CTs are used basically in hierarchies or sequence generation or graph traversal or chains, tree structures. So these are the applications where you can use the recursive CTs. Now we'll go to the MySQL workbench and see some examples related to recursive CTs. Now let's say I want to generate numbers 1 to 10. Okay, I want to generate the numbers 1 to 10. If I write a query, select 1 as n, and if I run this, what I'm going to get is 1. Column name is n, and I'm going to get display the number 1. Okay. So, but I don't want now like this. I want numbers from 1 to 10. So it should display like 1, 2, 3, 4 up to 10. Okay. First thing, whenever you're writing a query for recursive CTE, important is to identify the base case and the recursive member and the stopping condition. Okay. So here what can be the base case? Base case here will be starting point. What is the starting point? Starting point is 1. I want to display 1, number 1. What can be the recursive member? After 1, I want 2. After 2, I want 3, then 4. Basically, I want that number plus 1. Whatever number I have now, plus 1. So if I have now 1 plus 1, 2, then I will be getting 2. Then 2 plus 1, 3. 3 plus 1, 4, like this. So if I call this particular number as n, my recursive member will be n plus 1. N plus 1. Okay. Now, till when I need to repeat this particular thing? What can be the stop condition? Basically, I need to generate numbers from 1 to 10. So my stop condition will be where n is less than 10. Why less than 10? Because if my n is 9, then 9 plus 1 will be 10, then it will get displayed 10. But if my n is 10, it will be 11. So my stop condition will be less than 10. So these three things, base case, recursive member, and stop condition, we have identified. Now we have to put that in the syntax. What is the syntax? With recursive, with recursive, and you have to give a name to our city, let's say numbers, as, and here we will write our query in two parts. One is the base case. First one is the base case. What is the base case here? Base case is first you have to print 1 or select 1. So I can write here select 1 as n. This is my base case. And the next thing I need to write is recursive member. Recursive member is nothing but n plus 1. Repeat n plus 1 till it is less than 10. That is a stopping condition. So my recursive member here will be select n plus 1. Correct? From what? Now from what this n we will select? We'll select this n from this base case. And this base case is where? Where is this base case? This base case is in the virtual table numbers. So that is select n plus 1 from numbers. Correct? But I need to also give some stopping condition. Correct? The stopping condition will be where n is less than 10. If my n is less than 10, that is the maximum number it can have is 9. So 9 plus will give me 10. And I want the numbers from 1 to 10. Okay. Now, this particular result is separate. This particular result is going to be separate. But I need to call this recursively n plus 1 till n is less than 10. And lastly, I need to join these two results. Correct? Or I need to combine these two results. I need one also and these results also. For that, we are going to use the operator that is union all. Union all will just combine these two results. Correct? Yes. Now, is my query completed? This is nothing but this is my recursive CTE basically. But I need to display now this recursive CTE. So I can write here select star from numbers. Now this completes my recursive CTE. If I run this particular command now, then I will get all the numbers from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. If you want the pass by pass working of this, I can show you it for the some passes. Let's say working pass 0. Okay. Pass 0 is nothing but the base condition. In this case, it will just rows produced will be 1. Rows produced will be 1 here in this case. Correct? In pass 2 or sorry, pass 1. Pass 1. In pass 1, what will happen? Now, currently I have how many rows? I have 1 rows. That is 1. Is 1 less than 10? True. Correct? Then it will increment 1 plus 1, that is 2. Then it will go to pass 2. Pass 2. Currently, which row I have read? 2. Is 2 less than 10? True. Now it will produce 3, n plus 1, 3. And this will go on so on till pass 10. Pass 10, what will happen? Or I can say pass 9. In pass 9, I will get here 9. Is 9 less than 10? Yes. It will be true. And now it will get incremented by 1 and it will be showing you the output as 10. Okay. Now it will go to pass 10. where I have the row's value as 10. Is 10 less than 10? It will be false. Now here it will be empty basically. Okay, empty means nothing but stop. So this is how the working of the recursive CTEs. Base condition, then recursive member, then stopping condition. And done. Now we'll try to solve more examples of recursive and try to understand it in more easy way. Okay. Now let's say I need to generate even numbers only. Even numbers from 2 to 20. I want 2 also and 20 also, including 2 and 20. Okay. So I can directly write the code with recursive. Let's say my recursive CT name is even numbers as, and here I will write the query. So first is my base case. What is the base case? I want the number from 2 to 20. So base case is first print 2. Second, write select 2 as n. Correct. This is my base case. And then union all. And here I will write the recursive member. Recursive member. 2, then 4, then 6, then 8. These are even numbers. What is the difference between this? 2. So if I do 2 plus 2, it will be 4. 4 plus 2, 6. 6 plus 2, 8. Basically, we need to add to whatever result we have. In that, we have to add 2. So basically, we need to select whatever result we have, that is n plus 2. And from where I will get this particular n, I will get it from this particular CT only even numbers. From even numbers. Do I have any stopping condition? Yes. My last number should be 20. It means that my n, whenever my n is 18, it will be 18 plus 2, 20. 20 should get displayed. Then after 20, 20 plus 2, 22 should not be displayed. So I can write where n is less than 20. Correct? So this is my recursive member basically. And lastly, I need to write the query select star from even numbers. If I execute this particular thing, I will get all the even numbers 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 from 2 to 20. So I hope you understood this. Let's move to the next question. Generate multiplication table of 5. Okay. So this can be done in 2 ways. I can do it like this also. I can write the same query here. So here I'm just changing the name. Let's say table 5. And here also I'm writing table 5. And here also table 5. Okay. And here instead of 2, I will add it to 5. Correct? And select initially 5. So 5, then 5 plus 5, 10, 10 plus 5, 15, plus 5, 20, plus 25, 30, 35, 40, like this. And I want it till 50. Let's say 5 tens are 50, till that I want. And if I execute this, I will get the answer 5, table of 5. Correct? So this is the one way of writing. Another way, another approach. So another approach can be, we can write it like this with recursive table 5 as, okay. And here I can write select 1 as n union all. And my recursive member will be select n plus 1 from table 5 where n is less than 10. Okay, so this is basically nothing but writing natural numbers from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct? Now, how I can generate table of 5 from this? So when I'm writing the query, select n from, let's say, table 5. If I execute this particular query here, I will get all the natural numbers from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 9, 10. Now, I am now writing like this, n comma 5 into n from table 5. And I'm displaying this table as, or this column as result. Now, if I run this particular query, you can see here I will get when n is 1, result is 5. When n is 2, result is 10. That is 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 fours are 20, 5 fives are 25, like this. So this is more readable, correct? So this is another way you can also use the recursive CTE. So I showed you both the ways, first way and second way, correct? So I hope you understood how we use recursive CTEs. Now these were very simple examples. Now we'll try to jump to the intermediate example or more advanced example. So now we'll try to use recursivity for employee hierarchy dataset database. So let's say create a table, employees. Okay. Let's say it has employee ID in primary key. Then let's say employee name, varchar 50 and manager ID. So this particular example we saw at the starting of this video, correct? Manager ID int. So let's create this particular table. Execute. What is the error? Okay, no. So I need to create a database first. Create database. Let's say Recursive CTE demo and use that particular database. Okay. So let's run this particular queries. Now I will create a table inside that database. Created. Now I want to add the values inside this. So let's insert these values, insert into employee values, CEO, manager, and so on. The same example what we have discussed. Okay. Now if I write select star from employees, so you will able to see here employee ID 1 CEO, manager ID no, null. Manager A, manager B is managed by CEO. Employee 1, employee 2 are managed by manager A. Employee 3, employee 4 are managed by manager B. Basically, this is the hierarchy base. Now, how we can use recursive CTE in this case? Let us try to understand that now. So first query that we will solve today is finding everyone under the CEO. Finding everyone under the CEO. That means I want the first to be CEO, then manager under CEO, then employee under that manager, one or employee under manager two, like this and so on. Okay. So how to display this? First, we have to identify what is the base case. What is the base case? We have to start with CEO. First row should be CEO. That is at the level 1. So basically, we need to display it level wise. Level 1, level 2, level 3. So here CEO will be my level 1, manager A, manager B will be level 2, and employees will be level 3. So my base case will be level 1, that is CEO. So basically, I need to display CEO as a base case. So base case will be start at the CEO. And what will be the recursive member? What will be the recursive member? You have to find direct reports of everyone. What do you mean by direct reports in everyone? Basically, when I'm at the manager A, I will see whether this manager ID is equal to the previous employee ID or not. Yes, 1 is equal to 1. Yes. So that means this particular manager is at the level 2 and it is managed by CEO. Similarly, manager B is 1 and manager ID is 1, that is equal to the employee ID of CEO, like this. So here we need to compare the employee ID and the manager ID. So let's try to write the query now with recursive, then CTE name I need to give. Let's say employee tree as. Now I need to provide the query here. First is the base case. What is the base case? Start at the CEO. So I need to select the employee ID, comma, employee name, okay, comma, manager ID. I'm selecting all the columns basically, comma, 1 as label. Why I'm writing 1 as a label? Basically, I need one more column to display the label of that particular employee. So Since the base case is I'm selecting the employee ID with 1. So where I'm writing here where employee ID is equals to 1. Employee ID is equals to 1 means it is CEO. I want to start with CEO. That's why the base case is CEO. It will return only one row. That is 1 CEO null and label as 1. Now this particular label is another column, fourth column that I am going to create. I want to display it. Now I am displaying that label as 1 because CEO is level 1. Correct? So I hope you have understood till this. Now we'll try to write the recursive query. Recursive member. Now what will be the recursive member basically? So in recursive member also we want the employee ID. We want the employee name as well as we want the manager ID. In this case also we want this particular three things: employee ID, employee name and manager ID. And we want the label. But the label of CO is 1. Once it comes to manager, the label becomes +1. It will become level 2. And when it goes to employee, it will become level 3. So in this case, I need to do level +1. From table employees, and I'm giving the table alias as E. So that since I've given the table alias E, here I need to write E.employee ID, then E.employee name, E.manager ID. But I can't write E.level because this particular in this particular employees table, there is no column level. This level column is present in which table? It is present in the employee tree table. So basically, I need to join this table with the employee tree. Correct? ET. Let's say table alias is ET. So here I need to write ET.level +1. So till now it is clear. Now, what is the join condition? The join condition is where I to join, wherever the employee ID is equal to manager ID. So which table's employee ID and which table's manager ID? So we need to join it on employee table's manager ID. Correct? This is my employee table's manager ID. It should be equal to the employee tree, this particular table's employee ID, et.employee ID. Okay. Now this is nothing but my recursive member basically. Correct? Now we need to write a one query, select star from employee tree. Okay. And to combine these two results, I need to write here union all this. Okay. Now if I run this particular query, execute, what is the employee ID in the field, unknown column employee ID. Okay. So I'm getting the error because in this base case, I forgot to write the from employees. That's why it is showing error for employee ID. So I need to write here from employees. Yes. If I run this particular query now, execute. So here I will get the result. Employee ID 1, CEO, manager ID null, and level is 1. Then for manager A and B, I'm getting manager ID 1, 1. For that, the level becomes 1 + 1, that is 2. And for all the employees, the level becomes 3. And the manager ID and all of these things. So this is how it is working. Now, in actual how it is working, let's see the working steps. Okay, pass by pass how it is working. So initially pass 0. That is my base case. In this particular base case, my join condition is employee ID is 1. And the new row will be produced is only one, that is CEO. Basically here I will get the first row, that is CEO. Next pass. Pass 1. Here my working table now has one record, that is one CEO. Correct? Now E.manager ID is equals to 1. Now to understand this, I will just select star from employees. I will run this particular command so that you will get it more clearly. Okay. Now in the past one, currently I have only one record, that is CEO. Now the manager ID is 1. Manager ID is 1. Correct. Now wherever the E.manager ID is 1 and it is equated with employee ID 1. So wherever there is manager ID 1, that particular will get the label as 2. In pass 2, now I will have two records basically for manager A and manager B. So I will get 2 for manager A and 3 manager B. So these 2 records I will have. Now here it will compare the manager ID, E dot manager ID in 2, 3. It is either 2 or 3. That means employee 1 for it, employee 1 it is 2, employee 2 it is 2, employee 3 and employee 4 it is 3. So it is 2 or 3, it will give the level as 3. Now in pass 3, I will have 4 records basically. I will have 4 records. That is nothing but employee ID 4, 5, 6, 7. Employee 1, employee 2, employee 3, employee 4. Now it will check whether any manager ID is 4, 5, 6 or 7 or not. There is no manager ID with 4, 5, 6. So it will return empty. That is nothing but stop. So I hope you understood the rough working of this particular query. So let us move to the next query. Now the next query is finding one employee's full reporting chain. What do you mean by reporting chain of employee? So our goal is to find like this. Goal is employee 1, then their manager, then their manager's manager, manager's manager, and it will go on so on till CEO. This is nothing but the employees reporting chain. So particular employee will report their manager will report their manager, then its manager, like this till CEO. This is the reporting chain. Let's say I need to display the reporting chain for employee 1. In our case, it will be employee 1 to manager is 2, that is manager A, and manager E to CEO. This will be there in our case. But it might happen that there will be so much of levels in real world data. So in that case, the levels will get further divided. In our case, there are only 3 levels. Okay, let us try to write the query to display this particular chain. So what is the base condition here? Base condition is I have to first display the employee. Let's say I'm doing for employee 1, that is employee ID 4. So here my base condition will be select that particular employee with employee ID 4. So I'm going to write with recursive manager chain as. So here my base case will be select the employee ID, comma the employee name, comma the manager ID from the employees where the employee ID equals to 4. Basically, I'm writing the manager chain for employee 1 or employee chain for employee 1. So for employee 1, the employee ID is 4. That's why I wrote here. That's why the employee ID is 4. So this is my base case. Now what is recursive member? Recursive member. So now I've selected the employee 1 displayed it. Now I have to check the manager ID. It is 2. And this particular 2 is which employee ID? Employee is manager A. Basically, this particular manager ID is 2 and this 2 is nothing but employee name manager A. So how I can check this? And then again manager A, manager ID is 1, which is nothing but CEO. Okay, so in recursion, what I need to write? In recursion also I need to select the same thing, employee ID, employee name, manager ID. Correct? From employees table, employees E. Giving the table alias E. So here I have to write E dot employee ID, E dot employee name, and E dot manager ID. Here it should be comma. Okay. Now, so here also we need to join the table so that we can apply the condition of employee ID equal to manager ID. But the important thing is here to identify which tables manager ID we have to take and which tables employee ID we have to take. So in this case, our base case is we have displayed the employee and we have displayed this employee in the manager's chain table. That is virtual table. So basically we have to compare with manager ID of the manager chain table and employee ID of the employees table. So here we need to join it with the employees table. Sorry, join it with the manager chain table. manager chain table as, let's say, MC on the condition MC dot employee ID is equals to E dot employee ID. Sorry, here it should be manager ID. Whatever these tables, manager chain tables manager ID should be equal to the employee tables employee ID. In that case, we'll select that particular employee like this. Okay. I hope you understood this. Now, in last, we need to write a select star from manager chain. Manager chain. If I run this particular query, before that, I need to combine this result using the operator union or. Okay. If I execute this query, I will get employee. It will start from employee 1, that is employee ID 4, employee 1, manager ID 2. Then next thing it will check in which condition this manager ID 2 is equal to the employee ID 2. So that it is found for manager ID, employee ID 2, that is manager name manager A. Now in my table, I have this particular record 2 manager A1. Now it will check in this manager chain table, manager chain dot manager ID, that is 1, is equal to E dot employee ID. Where is E dot employee ID 1? That is for CEO. Then it will display 1 CEO. Now here the manager ID will be null and there is no such record where null is equal to null. Then it will stop and then it will give the result. So I hope you understood this particular thing. Now whatever examples we solved, in this case the data was really good. Now what if my data is bad? Bad data. I will just show you example visually. Let's say my data is something like this. A is pointing to B, B is pointing to C, and C is pointing to again A. So this is a problem basically. C is pointing to A. So if you try to apply a recursive CTE, what will happen? At pass 0, let's say you try to display employee A. Then at pass 1, you will display A is managed by B, whatever. Okay. Then again at pass 2, you will have B. B is managed by C. Then again in pass 3, what will happen? You have C and C is managed by A. Then again you will be having A. In pass 4, you will be again having A. And this thing will again repeat A to B, B to C, C to A. Again A to B, B to C, C to A. This is the problem. Okay. So this will naturally never stop basically. This will never give us an empty pass. How we can prevent this basically? So we can prevent this by using something called as max recursion. So let's say I'm writing a query with recursive numbers as, let's say, select 1 as n, union all, select n plus 1 from numbers where n is less than 1000. And I'm displaying here select star from numbers. Okay. If I run this particular query, what I'm going to get? Numbers from 1 to 1000 basically. 1 to 1000 all the numbers. Now I'm writing one command, show variables like CTE max recursion depth. And if I run this particular thing, I will get here 1000. That is maximum recursion depth is 1000. And here I have mentioned 1000. Now similarly, if I write here 2000, it will give me error. It will give me error that recursive query aborted after 101 iterations. Sorry, 1001 iterations. Because the maximum recursion depth by default value was 1000. Now how to prevent this particular thing? That is pass 0, pass 1 and this. So it will run so on. But this will only run till 1001 iterations only. But if you have to stop this particular in 5 iterations or 10 iterations or 50 iterations, you can now change this particular limit. So you can write here set session CTE max recursion depth is equals to, let's say if I write here 2000, it will become 2000. Let's say if I write here 10, it will become only 10. It is executed. Now if I see the value, show variables like CTE max depth, it is now 10. So if I write here something like this, less than, let's say 20, now it will not work because I have set the depth to 10 only. So it will show me the error recursive query aborted after 11 iterations. So I hope it is clear how you can reduce this, how you can solve this particular problem of unlimited recursions. So I hope you understood about the recursive CTEs. Now let us do one comparison of normal CTE and recursive CTE. Normal CTE versus recursive CTE. So basic comparison, orally I can do. So in normal CTE, you don't have a self-reference basically, self-referencing. But in recursive CTE, you have self-referencing. Second point is about hierarchy. It cannot work in hierarchy. Normal CTE cannot work in hierarchy. Or it cannot work in graph problems, graph traversal. Or it cannot work in generating a sequences. Whereas the recursive CTE can work in graph traversal, generating the sequences, or these kind of things. Then in normal CTE, we don't use the union all operator, but in recursive CTE, we need to use the union all operator so that we combine the base case and the recursive member. Okay. Then next thing is about a normal CTE will run only once for that particular query, but recursive CTE will run multiple times. The risk of infinite loop, that what you have discussed now about this particular thing, pass A to B, B to C, C to A. This is nothing but infinite loop. So there is no risk of infinite loop in normal CTE, but there is a risk of infinite loop in recursive CTE. And to prevent that problem, we can reduce the max recursion depth at particular value so that we can identify whether it is in an infinite loop or not. Okay. So I hope you understood today's video. If you find this video interesting and helpful, do like, share and subscribe to the channel for more such videos. Thank you so much for watching. Keep learning.